everyone, I am Julien Dubois. I'm a Principal Engineering Manager at Microsoft, and today we're going to talk about deploying Quarkus applications to Azure. Quarkus has got two deployment modes. There is a GVM mode using the normal Java virtual machine, and there is a native mode using GraalVM, and that's the one everybody is excited about. Today we're going to do both, so you can compare them and choose the one that you think is better for you. We're going to use some tooling for that. We're going to use Terraform in order to generate our Azure infrastructure. We're going to use GitHub Actions to automate everything. And last but not least, we're going to use a tool called NubesGen, which I am working on, which automates everything. So that's going to make it a lot easier for you to do everything that I'm going to show today. If you want to do the same as me, you can go to our documentation here. We've got a specific section on Quarkus. And here you've got full tutorials on using Quarkus with the GVM or with a native build using GraalVM. Let's get started. I'm going to go to code.quarkus.io to generate a simple Quarkus application. I'm going to use REST-easy to do some REST endpoint. Let's generate the application, download the zip file and zip it. And let's open it up using IntelliJ. First thing we're going to do is share this on GitHub. As we said, we want to use GitHub Actions, so of course we need GitHub for this. But anyway, it's always a good practice to have everything in Git. So let's share the project on GitHub. I'm going to call this project demo, and I'm going to make it private. Demo private. Let's share it on GitHub. Once it is shared, we're going to be able to code and deploy it quickly on Azure. Let's just go to my GitHub account so we can see that everything is good. So let's have a look at my repositories, and let's have a look at demo, which is our newest repository. It was committed 14 seconds ago, so that's the one I just created. Now we're all set up, we can start working. Quarkus gives us a nice documentation out of the box to run Quarkus in development mode. So let's do this, and let's have a look at what was generated. So it's a simple hello world saying hello REST-easy, because that's the framework that we're using for the REST endpoints. So if we go here to localhost 8080, we're going to have Quarkus dashboard arriving. And if we go to the hello endpoint, we've got hello REST-easy. Everything is running fine. Very happy about that. Let's get started. Let's get coding. I'm going to change this to Hello Azure. And as we go to test suite, which validates that text, I'm going to remove the test here. As Quarkus has got auto reload, I just reload my page here, and now I've got Hello Azure instead of Hello REST-easy. So as we've seen, I'm able to code very easily my Quarkus application. I'm going to commit that to GitHub, hello, push, and that's the normal workflow that any developer would do. Now that I've set this up, I'm going to deploy all of this to Azure, first using Java and then using the native build. For that, I'm going back to NubesGen, and I'm going to do two steps. The first one is running this bash script. So let me run it first, and then let me explain what this is all about. So create a new terminal, run it. So the script is doing two things. First of all, it's creating an Azure storage account. This is for Terraform, as we're going to use Terraform with a continuous integration and maybe with other people. We need a shared Terraform state, and the good practice here is to share that state on Azure. We deploy to Azure, and we share the state of Azure on Azure. That's the most logical thing to do. And it's very easy to do once it's configured. Second thing that this is doing is this is creating two secrets on our GitHub account. Let's just go to our GitHub demo repository. If we go to settings here, we're going to have two secrets created here. The most important one is the first one, the Azure credentials. So this is going to give Azure credentials to my GitHub account, so my GitHub account can access my Azure account and create some resources over there. If I go back here, here are my two secrets. the most important one being, of course, the credentials to Azure. This is how everything is going to work. Now that I've done that, I'm ready to deploy my project to Azure. So I'm going to create a new branch for that. I'm going to call it env-java. And in that branch, I'm going to go to the main NubesGen website. And I'm going to call NubesGen to generate the Terraform configuration that I want. So my project is called demo. I'm going to deploy it to France because that's where I live. I'm going to select here Quarkus Java. You can see here Quarkus native just underneath, so that's the one we will use in a few minutes. We're going to use a basic application. We don't need something very powerful. Then there are many other options on NubesGen, like you can select database, you can add popular Azure services like Application Insights or Key Vault or Blob Storage. They all work with Quarkus. Everything is configured. I'm just not showing all of them because it would be too long. And the important box to tick is this one, add GitOps. If you don't do this, well, you can do everything manually, but if you use GitOps, well, thanks to the GitOps methodology, you will be able to just git push your code to production. That's much easier to do, so I highly recommend using it. Here, I can download this as a zip file, exactly like we did with Quarkus. It's exactly the same way of working as code.quarkus.io. You can also use a curl script. I'd rather use a curl script. I find it easier, but it's a personal choice, of course. So I copied the curl script, and here in my Quarkus application, I'm going to apply it. And as we can see, it generated some files. So let me commit those files first, and then let me describe what was created here. So I'll say deploy to Azure, and let's say git push. And we're going to have a look at what was created. So this created two sets of files. The first one is in this Terraform directory. So this is Terraform configuration to deploy my app to Azure. The most important file is this one. We can see we're using an Azure App Service Terraform configuration. We're using Linux. We're having a basic tier here, and we're using Java, even Java 11 here. That's the first set of files. And then there's one more file that was created. That's because we wanted to use GitOps. This created a specific GitHub workflows that is going to build my code and deploy it to Azure automatically. So let's not look at this code. Let's have a look at it running because it's already running right now. If I go back to my GitHub repository, if I go to Actions, I can see here my GitHub action running. So that's the one I just created 43 seconds ago. And if I click here, we can see we've got 3 jobs. The first one is creating my Azure infrastructure using Terraform. So that is creating an Azure App Service with Java, and that's where I will deploy my code. The second thing is this build job. So this is building my application using Maven, which was a normal Quarkus build using Maven. Once those 2 jobs, which run in parallel, when those 2 jobs will be finished, everything will be deployed to Azure, and our Quarkus application will be running on Azure with the GVM mode. That's going to take a few minutes. It's pretty fast, but let's not waste time, and let's go back to this later. Now let's create a new branch to deploy our application natively using GraalVM. So I'm going to create a new branch here that I call env native. In that new branch, I'm going to call NubesGen again, but this time using the native build of Quarkus, and everything is the same. Copy the curl script, and apply it. Do it manually, git add, git commit, deploy to Azure. Oh, hang on, let's change something. I'm going to change the text here. We have hello Azure for the GVM mode. Here, let's say hello Azure with GraalVM. So we can see that it's really working fine. So let's add this also. It also deploy to Azure. And now say git push. And I need to set up my new branch. Now let's go back to our GitHub Actions. So the first GitHub action is running, that's deploying to Azure App Service using Java. And we've got a second action now running, which is the one using the native build. So we can see our two branches. Here we've got the Java branch and here the native branch. The Java branch is deploying using the GVM and the native branch is deploying using GraalVM. Let's first have a look at the Java deployment, which is nearly finished. Let's have a look at our Azure resource groups. So this has created a new resource group, which is called rgdemo some numbers Java 001. So you can see that this name is a bit specific, and inside we've got some very specific names for our app service instance and our app service plan. If you don't know what a resource group, app service plan, app service are, if you don't know about them, that's cool, because here, thanks to NubesGen and Terraform, everything was generated for you, so you don't need to know exactly what those are. If you want to know more, of course, you can go to the Azure documentation. You can also see that we've got some very specific names. That's following the best practices from the Azure Cloud Adoption Framework. So here we generate for you good naming for all your Azure services, which is not obvious at first when you get started with Azure. And well, we select the best options for you by default using NubesGen. Let's have a look at our app service instance here. So normally we should have deployed to it. Yeah, everything is deployed. If we go here to the deploy job, we can see it was deployed. We even got the URL. If I click here, hopefully my Quarkus application will be running. And it's not yet. It's probably still deploying. So we need to wait a little bit. So let's get back to our Azure App Service instance. Let's have a look at the logs. This is because we're using the Java build. The Java build is taking maybe between 7 and 10 seconds to deploy. As you can see, it's being deployed. It's deployed. It took 19 seconds. Honestly, it's a little bit slow. Usually it's a bit faster, but that gives already a good comparison between the Java build and the GraalVM build, because you can imagine it would be faster with GraalVM. And now that it's deployed, if we go there, we've got Quarkus running. And if we go to the hello endpoint, we've got hello Azure, which was the text that we had for the Java deployment. So this is fully working. It took some time to deploy, but then the build was a bit fast. It's going to be faster also because everything is cached and we don't need to recreate the resources every time. So usually here you've got a deployment time of about 1 or 2 minutes, depending on what you do. It's pretty fast. Then it takes, so usually it's mostly around 10 seconds to deploy, depending on the machine that you take. Again, this time we were a bit unlucky, but that's happened. That's part of the game with Java. This is all working. Now let's go back to our GitHub Actions. We can see the second action is still running. So that's the native build. So this time we've got just one build for everything. We don't have 3 jobs like before because we've got some constraints. Here we're using an Azure Container Registry to host our Docker image. And that forces us to do everything in one job because we first need to create the container registry and then to deploy to it. So we can't do stuff in parallel like we used to do before. But that's not the only reason why this is slower. This is also slower because we're having a Maven build that takes some time because that calls GraalVM, and the GraalVM build takes typically 4 minutes on GitHub Actions for something as simple as this Hello World app. So let's have a look at what was created because Terraform already ran. So let's go back here to our resource groups. And we'll go to a new one, which is a native build. Here it is. So here we can see we still have an app service instance and an app service plan, but we've got this new thing, which is a container registry. So this is where our Docker image will be stored. It is specific to using GraalVM because when you use GraalVM, you're going to build a Docker image and you need to host the Docker image somewhere. So you need another container, an Azure container registry for that. That's why it's a bit more complex also to deploy while using the native build because you need that container registry also that you didn't need when doing Java. If you use NubesGen, like we just did, NubesGen generates everything for you, so you don't really feel the pain. And from a cost perspective, it's extremely cheap, so it's basically the same price. But well, you need to know it's a little bit more complex here if you use GraalVM. Let's have a look at our build. While it's being finished, we can see that GraalVM is running and it it's taking some seconds to deploy everything. We can also see it's taking quite a lot of RAM. If you use GitHub Actions, this is really cool because GitHub Actions are very powerful machines, so it's not really a big deal. By the way, GitHub Actions is running on Azure, so this is also running on Azure. And in a little bit less than 4 seconds, we will have 4 minutes. We will have our GraalVM native build running. Then we need to build it with Docker, push the Docker image to the container registry, and then to deploy it. So as you can see, this whole setup is a little bit longer than we used to have. When we will do more builds, so there is some caching and so on, so it's going to be a little bit faster, but not that much faster. So usually deploying with GraalVM text, I would say between 5 and 6 minutes compared to 1 or 2 minutes using Java. So deploying here takes more time, but once it's deployed, your app is going to start much faster, which is what you want with GraalVM. So you lose on the build time, but you win on the startup time of your application. We can see here our application being pushed to the Azure Container Registry. And once the Azure Container Registry has got the app, we can deploy it to Azure App Service. Let's have a quick look here at our Azure Container Registry. So now it's not empty. We can see we're using 0.05 gigabytes. That's our GraalVM build. And if we have a look here, we can even see we've got a Docker image here that is available. So that's what we're deploying right now to our app service. And this app service, of course, doesn't use Java this time. It's using Docker directly. Let's just have a look here. Yeah, everything is being deployed. It's finished. Let's have a look at the total build time of everything. So yes, so deploying here took 3 minutes with Java, a little bit under 4, and a little bit under 7 minutes for GraalVM. Again, when we deploy those apps one more time, we've got cache. We're not going to generate the Azure infrastructure again, so it's going to be much faster. But the Java build will always be much, much faster than the native build. Let's go back to our app. First thing I want to check, even before having a look at our app, is my log stream. I want to see if my app started and in how much time did it start. It's supposed to be much faster with GraalVM, so that's what's interesting for us. We can see that the app deployed in under 300 milliseconds. So here's my app. And if I go to the overview, I can click here and I can see my application running. So that's again the Quarkus main page. And if I go to Hello, I got Hello Azure with GraalVM. So we know that's the GraalVM build of our application. Here again, we've been honestly a little bit unlucky. It's usually less than 300 milliseconds. Let me restart it to see if we can have a better startup time. But you can already see it's much faster than the nearly 20 seconds we had with Java. Let's go back to the log stream to see if we can see a better startup time. So the cool thing with Quarkus is that it starts so fast that here we're not afraid to start it and run it again. It's already startup. So it's very, very easy and very convenient to work with it. The second time was 150 milliseconds, which is, well, much better. So what we have seen today is that we can easily deploy a Quarkus application on Azure, both using the GVM and using the GraalVM builds. So the GVM build is so faster to run on the CI/CD, but it starts in between 10 and 20 seconds. Can be a little bit faster if you're lucky, but usually it's about 10 seconds. If you use the GraalVM builds, well, building it takes longer, but then starting up the app is much faster. So if you have some needs for scalability, for example, it might be more interesting for you. Also, both of those times are going to grow when your app grows. Here I'm doing a simple hello world, but if you have a much more complex app, you can see much longer build times for Quarkus. The GraalVM build can take much longer. But also deploying, starting up the Java application can also take much longer. So it's really a choice between build time and startup time. What's important to see here is that both of them work perfectly well on Azure. If you use something like NubesGen and GitHub Actions and Terraform, you can automate everything. So at the end, all I'm doing is git push. So what's important for your developers is that they've got the great developer experience of Quarkus, then they git push, and then they can have either the Java build or the GraalVM build, depending on what you choose. You can even have both of them if you want to. It's just a matter of your CI/CD doing the build and deploying it. It's very easy, and both of them work. So I hope you've enjoyed that demo. If you want to know more about NubesGen, please go to nubesgen.com. If you want to discuss this with me, don't hesitate to ping me on Twitter at Julien Dubois. And I hope to see you soon for another video on NubesGen. Thank you. Goodbye.